Continuing with our packet that we've been working on for the last couple of days, on number 24, we've got Mr. Franklin determined that the mean diving score for diver 1 was 8.1 with a standard deviation of 1.07. The mean diving score for diver 2 was 8.8 with a standard deviation of 2.24. Which conclusion could be made about the scores of the divers? So remember that the standard deviation is the spread around the mean. So if a number is smaller, that means it's less spread out than a number that's bigger. So for diver 1, the standard deviation was equal to 1.07. For diver 2, the standard deviation was equal to 2.24, which means that diver 1 had a smaller standard deviation and therefore was less spread around the mean. Number 25 you can skip, so number 26 says the table below shows the cost of a season ticket to an amusement park for various years. What is represented by the y-intercept of the line of best fit for this data set? So because it tells us about the line of best fit, we should probably take our table and put it into our calculator. So we do that by going to Stat and Edit. We're going to clear out anything that you see in L1 or L2 by hovering over L1 or L2 and hitting clear and then enter. And then you're going to let your x values be your L1s. So you would have 9, 14, 16, and 20. For your y's, you need to make sure that whatever is on the same row as 9 goes on the same row in your calculator as 9. So 9 was with $25. 14 was with 46.25. 16 was with 54.75. And 20 was with 71.75. Once you do that, to get your line of best fit, you would go to Stat, you would go to Calc, and you would do linear regression AX plus B, so number 4. Make sure your X is your L1, your Y is your L2. Make sure you store your reg equation and then hit calculate. So whenever you do that, you get that your line of best fit would be Y equals 4.25 X minus 13.25. So because in our linear equation, our y-intercept is always our b, that would be this number here. Remember that your b is your starting value. So what that would mean is, because our table says years since 1990, this value would represent our predicted price for a ticket in 1990. So that would be C. It is a little strange that it is a negative, but remember that this is the predicted price based on our line of best fit. So this definitely isn't the price. Nothing costs negative $13.25. But it is important that you recognize that it is the predicted price just by what our line of best fit is actually saying. Number 27 says, what is the area of the rectangle below? So remember, if we're finding area, the area of a rectangle is equal to length times width. So we would let one of these be our length and one of these be our width. So whenever we find our area, we would do 3x minus 2 times 2x plus 6. So looking at how this is written, we've got two sets of parentheses not separated by a plus or a minus, which means that we must be multiplying. When we multiply, we draw a box. So we would have 3x and negative 2 and 2x and positive 6. So inside the first box, we would have 3x times 2x, which would give us 6x squared. Inside the next box, remember we would do outside times the top, so 3x times 6 to get 18x. In this box, we would say negative 2 times 2x, which would give us negative 4x. And inside this box, we would say negative 2 times 6, which gives us negative 12. So then we would say 6x squared plus 18x minus 4x minus 12. So then we would find our like terms, which would be 18x and negative 4x. And so that would be 6x squared plus 14x minus 12, which would be B. $28 says a clothing store sells pants and shirts. The store can buy up to a total of 500 pants and shirts each month. The store wants to buy at least as many shirts as pants. The store wants to buy at least 100 pants each month. Which system of inequalities represents the constraints on the number of shirts S and the number of pants P the store buys each month? Okay, so what I would do is we know that the number of shirts is going to be S and the number of pants is going to be P. So where we see pants, we should mark it out and put P, and where we see shirts, we should mark it out and put S. I think the easiest one to start with is the store wants to buy at least 100 P each month. So that means that P is going to have to be at least, which means greater than or equal to 100. So all of these have P greater than or equal to 100. So then the store wants to buy at least as many shirts as pants. So that means that S and P are going to have an at least relationship, where S is greater than or equal to P. So I see that B and C both have that particular restraint, so we can get rid of A because it has S is less than or equal to P. And then the store can buy up to a total of 500 pants and shirts each month. So a total means that I'm going to be adding. So I'm going to be adding my shirts plus my pants, and it has to be up to 500. So I know that 500 is going to go here. Now because it says up to, that means that 500 is going to be the cap for that. So that's going to be the absolute biggest that it possibly could be, which means this part is going to have to be less than or equal to 500. So my answer would be C. 29 says a system of equations is shown below. Y equals negative 2x plus 4, y equals 2 to the x plus 1. What is the approximate value of x in the solution of the system? So for one, it tells us that we have a system of equations, and by looking at our two equations that were given, we can see that the first one is a linear equation, which means that it's going to give us a line when we graph it, and the second is an exponential equation, which means it's going to give us one of these like curved lines that either goes this way or goes this way. So what's probably easiest to do for this particular problem, since we know it's a system of equations and it's on our calculator active section, is to take both of these and graph them and look for the intersection. So to do that, you would go to your calculator and you would do y equals, and you would do 4y equals negative 2x plus 4, and the second one should be 2 to the x plus 1. Remember, to get the exponent, you would do the caret button, which is the button that's right above the division button, and then x, and then to get out from in the air like that, you would hit the right arrow to get to the right, and then you would do plus 1. So then you could graph it, and you would see that there is our line, so there's our linear equation, and there is our exponential equation. So what we're looking for anytime that we do a system is the place where the two graphs are going to intersect. So we're looking for the intersection right here. So to get that, we would do second trace, and then we would do the intersect option, which is number 5, and then we would hit enter, enter, enter. And when we do that, we get x equals 0.692153335 and y equals 2.61569333. The question, though, was asking us for the approximate x value in the solution, so we would be looking for this number or something that's closest to it. So A would be our answer. For number 30, it says the function y equals 45x plus 6 can be used to determine the cost for a person to purchase x tickets to a concert. A person can purchase up to 8 tickets. What is an appropriate domain for the function? Alright, so remember that domain means possible x values. So basically we want to know what values make sense for x. Now it says that x represents tickets, and we know that a person can only purchase up to 8 tickets, which means that we're going to have x is less than or equal to 8. So all of them have less than or equal to 8 in the solutions or in the answers. What we have to figure out is which one makes the most sense. All integers is anything that would show up on a number line. All integers would mean positives and negatives, but we can't purchase negative tickets, and remember that x represents tickets, so A is out. All positive integers would be our answer, but let's discuss why it's not C. So C says all positive real numbers. A real number is any number that can include decimals, but we can't include a decimal or a fraction when we're talking about tickets. You purchase whole tickets. So that's why we have to go with all positive integers, because integers are whole numbers that show up on a number line. (31) said, a liquid is evaporating. The amount of liquid remaining in liters after x weeks is modeled by the function or by the equation y equals 100 times 0.78 to the 3x. Approximately what percent of liquid evaporates per week? So as we look at this particular problem, we can tell that this is an exponential, and exponentials are always written in the form y equals a times b to the x, where a is our starting value and b is our rate, either increasing or decreasing. So we know that because it's evaporating that our value has to be decreasing, which means that our b has to be a number that's less than 1. But we can also see that our particular equation is not written quite this way, because our equation has a 3x, whereas the most basic exponential equation just has x. So what we need to do is get rid of this little 3 that's in the air. Now the only thing that's being raised to the 3x power is this 0.78. So what we can do is we can rewrite what we have here. It won't change the value of what we have, but it will change what it looks like. So we'll make it look a little bit more like an exponential equation that we're used to. So the only thing that's being raised to the 3x power is the 0.78, so we'll make it look like y equals 100 times, and then we'll go to the calculator. We'll do 0.78 to the third power. Remember, to get that third power, you would do 0.78, you would do the caret button, and then you would put a 3 up there. Hit enter, and you get 0.474552. To make it easier on us, we are going to round to the second place after the decimal, which means we're going to look at the third place and see if it's 5 or bigger. If it is, we'll bump up the 7. But when we look at the third place, it's a 4, so we're going to leave the 7, which means that we're going to rewrite our equation as y equals 100 times 0.47 to the x, because we've taken care of that 3 because we raised that 0.7 to the third power. All right, so Approximately what percent of the liquid evaporates per week? So when you look at this, you might automatically think, well, it's got to be A. But remember that whenever you are doing exponential equations like this, you always have to do something to B related to 1. So if your value for B is a number that is less than 1, then you would say 1 minus 0.47. If your number was bigger than 1, you would say that number minus 1. So you're going to do 1 minus 0.47, and whenever you do that, you get 0.53. We can change that into a percent by bumping our decimal 2 places to the right, which gives us 53%. So B.